Here is just some more algebra trig review, maybe part B. Some things the first one didn't cover. Law of sines, law of cosines, radians to degrees, degrees to radians, trig graphs, that sort of thing. Just trying to tidy up the chapter. Well, first, you know, if they give you a right triangle, you can just do sine of 39, x over 12, simplify, technically x is on top, so multiply, and you're good to go. But we know they don't do that to you all the time. So if I had 49 and 10, and obviously this is not the scale, 23 and x, there's no right angle. So I can't just use sine, cosine, and tangent. I have to do law of sines. And remember, law of sines is you've got to have a pair. So the side over the sine of the angle that's it's opposite from, x to sine 23. Cross multiply. So 10 times the sine of 23 equals x times the sine of 49. So basically, you're just going to divide 10 sine of 23. Okay. Divided by sine of 49. Let's see. I think that's going to be okay. Yeah, that's reasonable. 5.2. Or let's even say you're looking for an angle. Let's say they give you 125 and x. Hopefully this will work for us. 14, or let's say 11, just to be certain. Well, you got your pairs. So 25 to sine 100, 11 to sine x. So notice how we're still going to multiply this one, but we're going to divide by 25. And don't forget, since we're looking for the angle, we're going to do second sine. So 11 sine of 100 divided by 25, second sine, second answer equals 25.7. So that's law of sines. So if you have a pair, you know you can do law of sines. If you don't have a pair, like let's say 11 105 and 9, and you're looking for this one, that's when you can do law of cosines. Remember, law of cosines is x squared or p squared, a squared plus b squared minus 2ab cosine p, or in this case, x, since we used x there. So x squared equals, doesn't matter which one, because you're going to square them both and add them, so it doesn't matter, minus 211 times 9 cosine 105. Literally, you're going to plug it all in your calculator. 11 squared, or 121, plus 9 squared, or 81, minus 2 times 9 times 11 times cosine 105. So we get about 252. I'm sorry, 253. But remember, that's x squared. So we're going to want to do second, that button to do square root. Pull up our previous answer, 15.9. You can also use law of cosine when you're solving for The angle, like let's say if I had 12, 15, 14, and you're looking for the angle. We don't have a pair, so we know it's going to be law sign or cosines. So 15 squared equals 12 squared, 14 squared, minus 2, 14, 15. I'm sorry, 12 and 14. Cosine x. Now remember on this one, just like if I had 10 equals 3x plus 1, first you're going to have to get rid of whatever is in the term without the variable. So if there's your variable, we need to get rid of this. So 12 squared and 14 squared, oh looky there, 340. Interesting. 200, yeah, 340. 15 squared, 225. So you're going to subtract this over, so you get negative 115 equals negative 12 times 14 times 2. It was 24 times 14. 36 cosine x. So basically, you're going to divide by negative 336. Second cosine. So 115 divided by 336. Second cosine, second answer, 70 degrees. So you're going to subtract over the a squared and b squared. Divide by negative 2ab. Second cosine, second answer. So that's law of sine and cosine. Well, then we have converting radians to degrees, degrees to radians. So like if I had 40 degrees and I wanted to go 2 radians, so that means pi is on top. And remember, pi over 180 is just, unit multipliers. So 4s would cancel. 2 actually goes in there, so 2 pi over 9. Or if I had something like 330, you could multiply by pi over 180. And then 3 goes in there. So 11 pi over 6. Just like if I had something like 3 pi over 2 and I wanted to go to degrees, you're going to multiply by 180 over pi. Because remember, if you ever get a pi squared, you know something's wrong. The pi should always cancel or just simply be 1 on top. And 2 goes into 180, 90, 270. Let's even say 2 pi over 3. 180 over pi. 3 goes in there, 60. 120. And remember, you can also, what comes into play is if you wanted, like let's say sine of 2 pi over 3, convert it to degrees, and then it's just like the first half of the chapter. 120 degrees is 60 in the second. Square 3, 1, 2. Opposite over hypotenuse. Second sine is positive in the second. So you're done. Or if I wanted something like cosine of 3 pi over 2, we'll convert that to 270. And since that's straight down, cosine of 270, 0. So that's usually when you see radians to degrees, degrees to radians. Last but not least, graphs of sine, cosine, and tangent. We don't do a whole lot with tangent. We do more with sine and cosine. Sine will always, traditional sine will always fluctuate between 0 and 1. and will always go between 0 and 180. And remember, it starts at the center. And that's one complete curve. Every 360 degrees, it repeats itself in both directions forever. Cosine, also between 1 and -1, except for it, sorry, it's 180. Starts with 0. Starts at the top. And same thing goes on forever. It's actually just a sine curve that's been shifted 90 degrees. And then tangent, you can say between -90 and 90, or you could say between 90 and 270. If you want to do another one. A tangent's just a positive squiggle. Now, this is traditional sine and cosine. Let's say, however, though, they wanted to do a sinusoid, which is like a sine curve. You can have, I'll put everything on there because sometimes it's easier to see if there's everything. And then I'll take things away. Where the first number is the center line. So in this case, instead of 0, the center line's at 5. The 2 is the height or the amplitude. So you're going to go up 2, you're going to go down 2. It's positive sine. So it's going to look like that. We're going to come back to the 3 because that has to do with a period shift, period change. The phase shift is where it starts. So if it's x plus 50, we're going to start at what makes it 0 or -150. And last but not least, where the period comes in. If I just had something like sine of 3x, remember what that means is you would have your traditional sine curve, except in from 360. Let me scoot it over so I can draw it better. Yeah, and it's supposed to be ideal, but 1, 2, 3, yeah. So 360 degrees. So notice how every 120 degrees a new curve comes. Well, that's because 3 into 360 is 120. So that means from here to there is 120 degrees. So if you add it to -50, you get 70. Let's say if I did -6 for cosine, let's do a half, x minus 200. Okay, start off the same, center line -6, height of 4, so add 4, subtract 4. Cosine, so start at the top. Period change we're going to come back to. What makes that 0 positive 200? And then it's going to end. This one is a half. So rather than like this, where there were 3 different curves, this in a normal 360 degrees, it's only going to be half of it. So that means if you did 360 divided by half, just like over here we did 3, you get 720. So 200 plus 720, 920. There you go. Now let's say, let's put some things away and see if, like something like this. Notice how there's nothing out front. So the center line is 0. This 5 is our height. Sine curve. Nothing added or subtracted, so 0. And 3, well, we've already done 3. Let's say 4. 4 into 360 is 90. So 0 to 90. Now, of course, if you had negative sign, like 8 minus 2 sine of x, might as well do it. Center line 8, height of 2. But since the negative is right in front of the sign, instead of going up, we're going to go down. Starts at 0, and then 360 divided by 2, 180. So 0 plus 180. So that was kind of a recap. We didn't do reciprocal functions like the graphing of secant, cosecant, and cotangent. We'll get to those next year in pre-cal when we are not bombarded with this coronavirus stuff. I hope this was of help to you. If you do need those particular graphs, we will be doing them. I'll just post them at a later date. So that way it'll be of help in the meantime till we actually get to in the curriculum next year. Have a great day.